Now let's talk about solar yield. Solar yield estimation. How do you calculate, energy production from your solar panel? Now, in order to assess the energy yield of a PV system, one has to know about the available resource to the PV system, meaning the solar irradiation. There are a few ways anyway to do this, to do the solar yield calculation. So most of these softwares, what they actually use is they use solar irradiation, So if they know the solar irradiation per meter square of the place, and they know the efficiency of the solar panel or the solar module, then they can be able to calculate the yield of that, solar system. But there's another way to do this. Let me quickly move. So the economic feasibility of PV plants critically depends on its electricity yield, which in turn depends on both the meteorological condition at the location and the performance of the plant itself. As the electricity yield is heavily dependent on solar irradiation level, it is essential that the accurate and long-term climate data are available for the given location. Solar irradiation at a site is often stated in terms of the peak sun hour over a certain period. Furthermore, component quality, plant design, and layout are, as well as the maintenance plan, will affect the performance and consequently the energy use of the plant. So let us look at performance ratio. What is performance ratio? Remember when I told you that if a solar PV is rated, for example, 300 watts, that 300 watts peak is at a standard test condition, right? Now that is a factory level. The current is high. Now this line shows the current which is produced over a range of voltage. And this current is known as ISC. And this is ISC means short circuit. Short circuit. And short circuit current is the value at which the current is at maximum and the voltage is equal to 0. Now I want us to look at this formula. If this current, assuming that the sun is having its highest intensity, right? And the current is maximum, right? And this voltage is 0, what becomes the power? I just want
zero. Okay,
so this power becomes 0, right? Now, and when this happens, we know it is known as an ISC. That is at the point of where the current is maximum and the voltage is 0. Now, let us look at this diagram. This vertical axis is the current. The vertical axis is the current. Now, the horizontal axis is the voltage. Okay. Now, when this current is maximum, now the current is maximum. This is the current here is maximum, right? The voltage is what? 0. Okay. So at this point, your power is 0, right? Now, let us reverse this case. If your voltage is maximum, now your voltage is maximum, right? And your current is 0. What becomes your power? 0 as well. Okay, so now that presents a case